We're going to be going over question 22. Question 22 asks us, by using this graph on the left-hand side, to find the zeros in their multiplicity of the graph. Write the graph in factored form, then describe the end behavior and the y-intercept of the graph. Now, before starting this, let's just look over some key features of the graph. Well, we know that a zero is where the function touches or crosses the x-axis, so we have 1 at -2 and we have 1 at 2. We also know that the function has two turning points, which is when the slope begins to change from positive or negative to positive, vice versa. So we have 1 at around 1, and we have 1 at -2. We also know that our degree of our polynomial is equal to the amount of turning points, which is 2, plus 1. So the degree of our polynomial is going to be 3. We also note that multiplicity is the amount of times a factor appears in a graph, which that will be expressed by x minus c to some sort of power b, let's for say. And this b is dependent, is either odd or even, like all numbers are. And that is dependent based on if the function crosses the x-axis or rebounds through it, which is what this one does. This one crosses. And if it does cross, that's going to be an odd multiplicity, which means that b is going to be an odd number. And if it does not cross, like this here at -2, it's going to be an even number. We also know that x minus c is equal to our 0, where c is our 0. So we can then now write this polynomial out in factored form. X minus 2, and then x plus 2. And we know that, now first, before we move on, actually, let's give each of these, let's say that's b, and let's say that's m. And we know that the sum of these has to equal 3. We also know that m, which is our 0 right there, has to be even. So it has to be at least 2. And it can't be 4, because our limit is 3. So we have 2 is equal to 3, and then we have b is equal, so we have 1 plus 2 is equal to 3. So our x plus 2 factor has a square, and our x minus 2 factors has 1. So that's just x minus 1. So now we've kind of written the factored version of our function. We found the zeros, and we got the multiplicity. But next we need to talk about the end behavior and y-intercept of the graph. In order to do this, we're going to put the graph, or the function, to standard form, which is just by multiplying out all these terms, which gives us x cubed minus 2x squared, or plus 2x squared, minus 4x, minus 8. And this will allow us to evaluate the function when x is 0, which is our y-intercept. So when x is 0, and also, before we go into that, it should be -8 based on what our graph's telling us. So let's double check our work. Let's see if that's right. So 0 cubed plus 2, 0 squared, minus 4 times 0, minus 8. And this will then give us, once we do all the algebra, -8. And this is exactly what our graph shows us. So we know that our standard form is correct. And the y-intercept is 0, -8, as right here. Now, the last thing we're going to talk about is the end behavior. The end behavior just means as x gets really, really big or really, really small. So this is as x goes to infinity and as x goes to -infinity. And when we talk about end behavior, the only term that actually matters in a polynomial is its leading term, which is its term with the largest degree, which in our polynomial, p of x, it's x cubed. So we have x cubed. So what happens as our input into x cubed goes to infinity? X cubed also grows to infinity. So p of x, our function, is going to grow to infinity. But what happens when we input a really small term into x cubed, like -1,000,000, -1,billion, -quadrillion, -trillion, etc.? Our polynomial is going to become very, very negative. So as x goes to infinity, our function is going to go to infinity, and as x goes to -infinity, our function is going to go into -infinity.